Hello, students of Mass Communications 210, the history of media and mass communications once again, and welcome to presentation 11 in our lecture series, our video lecture series to conclude the course. Again, being presented in lieu of the advantages of face-to-face lectures under the current restrictions that we're facing. And as with the previous video lecture, I have uploaded the accompanying PowerPoint presentation to this video, also available under the weekly materials in the same section of the Blackboard LMS. And as before, once again, I will embed the images from the PowerPoint presentation into this video, and I will also verbally cue when it's appropriate to switch to the following slide in the presentation. And our topic for today, as it's listed in the course outline, is digitization or digitalization and the internet, largely surrounding the technological and industry changes that surrounded the turn of the millennium, that is the year 2000, immediately before and after. As well as touching on globalization, which is the topic of next week's class, as we proceed into that to conclude our course. So at this point, I'll invite you to proceed to the second PowerPoint slide in the accompanying presentation available to you on the Blackboard LMS. As we begin our discussion of digitalization and the internet simply by defining the term. At this point in the class, if we had the advantages of face-to-face or real-time interaction, I was going to inquire if anybody actually knew the definition of digitization or digitalization, or what digital means. Because it's a term that's thrown around generically quite a lot, actually, and yet many people don't actually know its very specific and surprisingly simple definition. Quite simply, digitization is the translation of information from various analog formats into patterns of ones and zeros, called binary, that can be read by computer systems, and that can also be transmitted along cables, fiber optic networks, telephone lines, over the air via radio waves, and then reconstructed by various kinds of electronic receivers, such as computers, cellular phones, DVD players, MP3 players, and so on, particularly cellular phones in the age of the World Wide Web. Now, in the past, it actually made sense to talk about distinct media forms, magazines, radio, television, cinema, as completely separate industries in their analog forms. And really, analog, when we set that in contradistinction to digital, simply means real time, where digital is actually finite. That is to say, it's a limited number of combinations of ones and zeros in the language of binary. Analog sound, for example, radio waves exist in real time space, and they're actually infinite. You can infinitely cut down, for example, a sound coming from a radio wave. You can infinitely cut that analog sound down into smaller and smaller and smaller increments if the human ear was able to hear it, in terms of increasingly small fractions of a moment of sound. Whereas with digital, at some point, you reach an increment of sound that goes beneath the digital language of binary that is reproducing the sound, and of course, that is the finite layer of it. Now, these media silos, of course, magazines, radio, television, cinema, which used to come to us as independent or individual, what are called silos of media. You'd buy your newspaper, you'd turn on your television, you'd go to the cinema, you might listen to the radio. These silos are, of course, breaking down in the age of the internet under the conditions of what are called convergence. Almost all media content today is produced digitally, with the result that it can be distributed both in its conventional analog form, that is to say, it can be printed as a newspaper or magazine, or it can be distributed through regular radio waves over the air, or on celluloid film, for example. You can print digital images onto celluloid film typically via the internet, but it can also be produced in its digital form so that it can be received through computers that are connected to the internet or things like your iPhone. And this phenomenon has significantly contributed to what has been called convergence. And there's no better illustration of media convergence and how telecommunication has evolved than the new generations of smartphones, which act as telephones, cameras, video and audio players, and personal computers, all in one small and handheld device linked in networks owned and controlled by communications conglomerates. Now, the commonality here is, of course, digitization, and hence the ability for one device to send and receive input from another is what is meant by the term technological convergence. And so, because this device, unlike a radio, for example, which can only receive radio waves through either cable or analog waves through the airwaves, your iPhone can, or your iPhone clone, whatever your smartphone might be, can not only receive digital information through the internet, often via Wi-Fi, but it can also produce digital information, unlike your radio at home or in your car that can actually not produce anything. All it can do is receive data through radio waves. Your iPhone can produce digital information, and it creates for a much more interactive and participatory form of media broadcasting. So internet technology actually led to many attempts at a name to set to this new medium, and its tech, as well as its technological offspring, things like the smartphone, and its siblings apart from traditional media. And in a 2001 book, Lev Manovich, who actually authored one of the contributions to this section of our textbook for the course, he made a case for the term new media, and of course that term caught on. The term old media or legacy media or traditional media refers to analog media like hard copy newspapers, magazines, books, film on celluloid, conventional radio, and conventional television broadcasting. The term new media, or again, convergent media, refers to digital media, computer-based technologies that are fundamentally now broadcast through the internet. Now, even so, there was confusion over products that spanned older and newer technologies, such as digitally delivered newspapers, for example. And new media was further blurred when actually it became just a buzzword for anything more sophisticated than a flashing neon sign in the world of advertising. It would be the first time that corporate interests have appropriated language in order to put it to uses that might sponsor their own product. In any case, the internet has emerged as the eighth major mass medium with a range of content, especially through web coding, that exceeds the traditional media or old media in many ways. And at this point, I will invite you to proceed now to the third slide in the PowerPoint presentation that accompanies this video lecture. Although in some ways the internet resembles a traditional mass medium that sends messages from a central transmission point, especially under the purview of corporate interests, it's much more interactive and participatory. As I said in discussing the iPhone, the ability to produce digital messages allows a much more immediate produce and receive feedback loop. The terms internet and web are often tossed around loosely, leading to actually quite a bit of confusion. The fundamental network that carries messages is the internet, and it dates to a military communication system created in 1969. And this system actually carried mostly, in fact, it carried exclusively text. So the internet had its origins in 1969 in a U.S. Department of Defense computer network called ARPANET, which stood for Advanced Research Projects Agency Network. The Pentagon built the network so that military contractors and universities, strange bedfellows to say the least, doing military research could exchange information. Researchers at the time were interested in developing an interactive computer network The original ARPANET project connected computer systems at 5 U.S. universities, enabling information and message exchange between them. And one of the key ideas behind the network was that in the event of a nuclear attack on the United States, in which one of these university-centered nodes was destroyed, the network could, of course, still function because it wasn't centralized. That is to say, the loss of any one of these points would not bring the whole system down, unlike a source-dominated broadcasting system in which bringing down the source of broadcast would, of course, interrupt the communications network. So the internet was developed thus as what's called a peer-to-peer system. There's no central control point in the network. And it also then became described as an end-to-end architecture, with the network itself remaining ignorant or at least neutral about what is being transferred. That is to say that the network itself is not necessarily monitoring the information that's being transferred. In fact, it can't, in order to maintain what's called net neutrality. And this feature of network neutrality ensures that all data being transferred receives equal treatment by the network. And the concept of net neutrality is at the heart of how the internet was defined, whether as a public good supporting democracy or as a commodity belonging actually to the market economy. And net neutrality has become a hot issue in terms of companies that have spent millions of dollars developing infrastructure over which they feel they should have control. But it's the same as the problems that were experienced by Bell with their early development of telephone technology and their attempts to maintain monopoly over the telephone distribution system, monopolies which were eventually broken by antitrust laws by the Supreme Court. So in 1983, however, the National Science Foundation, the NSF, whose mandate is to promote science, actually took ARPANET over from the military interests centered at these universities. And the network then developed by the NSF attracted more and more institutional users, many of which had their own internal networks, actually. For example, most universities that joined the NSF network had what are called intra-campus computer networks. And the NSF network then became a connector for thousands of other networks. And as a backbone system that interconnected networks, Internet was the name that fit, and now you have the history on the term internet. So at this point in the video lecture, once again, I'll invite you to proceed to the fourth slide in the PowerPoint presentation as I continue discussing the history of the development of the internet, a world of media that we so pervasively deal with today, that had actually this bizarre start with the American military before it went global, which I'll discuss more in the next lecture. Now, one of the obstacles to the internet becoming a universal vehicle for communication was that governments, universities, banks, and other institutions had local networks built on a polyglot of computer languages, like I mentioned in the ending part of the discussion of the previous slide. It was really a mishmash of incompatibility. But in 1974, two University of California at Los Angeles researchers, Vint Cerf and Bob Kahn, introduced a common language called Transmission Control Protocol, TCP, that allowed the local networks actually to talk to each other. It was basically a master language that accommodated all of the languages and then translated between the two of them. And for his contribution, Vint Cerf has actually come to be called the father of the internet. And the title also sometimes goes to Bob Kahn. But both are uncomfortable with the appellation. Cerf says that none of this was happening in a vacuum, that there was many participants in their ultimate development of TCP. So the early internet actually created access to a lot of data at speeds that were unprecedented. It was the new virtual library of information, which required really just the right technology to access it, literally at your fingertips. But it was an uninviting place visually. Text and data were in black and white, and they were image free, something really only a researcher could love. Even so, there were possibilities to take this new medium, the internet, in commercial directions, which ultimately resulted in the development of fiber optics. So while AT&T, also relevant to our historical discussion of telephones, was building on its off-on digital technology, that's the binary language I referred to earlier, to improve telephone service in the 1960s, actually Corning Glass developed a cable. Corning Glass, which is perhaps best known for its kitchenware, its dishes and cutlery, developed a cable that was capable of carrying light at incredible speeds, theoretically at 186,000 miles per second. It was apparent immediately that fiber optic cable could carry far more digitized message than the copper wire used for telephones. And the messages were encoded, as you can see in the image here in the PowerPoint slide, as light pulses rather than as the traditional electrical pulses used for transmission. And by the 1980s, new equipment to convert data to light pulses for transmission was in place. And long-distance telephone companies were replacing their copper lines with fiber optic cables, as were local cable television systems. With fiber optic cable, and other improvements, a single line could carry 60,000 telephone calls simultaneously. That's how dense and rapid the information was available through light pulses rather than through the electrical pulses of copper wire. And still, the internet was using the telephone system to carry messages. It was still limited mostly to only text. Images were still not available, certainly not moving images. Visuals were rare. Video, forget it. The number of data packets, they were called, the packages of information that needed to be unpacked and then recombined at the other end, at the reception end, for video was far too much for the system to reassemble in any sort of a reasonable time. But when the United States and Canada, and then the planet actually, after those two countries, were rewired with fiber optic cable in one of the greatest construction projects in media history, the internet capacity to scoot packets from point to point increased dramatically. Messages that had massive amounts of coding, such as video, actually became quite commonplace under these new conditions. And this process came to be called streaming, a term that, again, we throw around quite generically. And once again, now you know the history of where that term came from. Now, this early streaming, it certainly had reception that was jerky. And this might still be the case depending on the speed of your internet connection, but it's getting better and better all the time. And in fact, it became so improved over time that we had the emergence of full corporate media outlets like Netflix that depend entirely on streaming services. But also a new kind of company, internet service providers. ISPs went into business in the 1980s to give ordinary folks a portal to the internet and to help in navigating the internet's inherent complexity and at this point almost completely incoherent disorganization. A company called CompuServe was the first to provide online service to consumers. The ISPs, the internet service providers, like CompuServe, charged subscription fees for a combination of services, internet access, email, and most important, a mapping structure to help users get to where they wanted to go among the seemingly infinite number of disorganized places on the internet. And so, in terms of the internet's development and widespread use on a domestic scale, similar to the problems that were experienced with Bell Telephone attempting to create widespread domestic use of the telephone, we weren't out of the woods yet. Historically, there needed to be a number of elements put in place for the internet to work successfully as a domestic vehicle of media reception and sharing. And so at this point, it's time to proceed to the fifth slide in the PowerPoint presentation that accompanies this lecture video. Again, available in the PowerPoint link on the Blackboard LMS for this week of this course material. So a major breakthrough in overcoming these barriers to the widespread use of the internet came from English engineer Tim Berners-Lee. He was an Oxford engineer who in 1991 devised an addressing system that could connect every computer in the world. Berners-Lee actually explains that he came up with the web concept because he couldn't keep track of all of his notes on the various computers that he was using in various places. So, computer at home, computer at work, computer at the university, as well as at the CERN lab. I'll come to that in a minute. They weren't connected. And so he was always wondering where he had something saved. And the name that Berners-Lee came up with for his system, the World Wide Web, it sounded audacious, but it was actually quite accurate. A decentralized global network with the potential, theoretically, for everyone at a computer to communicate with everyone else at a computer anywhere on the planet. So history likes to suggest that Berners-Lee single-handedly invented the World Wide Web. And then he devoted his life to refining the web as a medium of communication open to everyone for free, which is part of the concerns relating to net neutrality that I discussed earlier. But going back in time a little bit, let's talk about Berners-Lee's story. It was 1989 when Berners-Lee was working at CERN, probably the most sophisticated physics lab in the world, located in Switzerland, which deals significantly with particle acceleration. And working at CERN, Berners-Lee proposed a system to facilitate scientific research by letting scientists' computers tap into each other. And in a way, the software worked, as Berners-Lee describes it, the same way as a brain does. In fact, Berners-Lee said that the idea was to keep track of all the random associations one comes across in real life that brains are supposed to be good at remembering. And Berners-Lee, his invention was built on three specific components. The Universal Resource Locators, which we call URLs, now actually known as the Uniform Resource Locators. And this addressing system was devised by Berners-Lee to give every computer a unique identifier, much like a postal address that enables a mail to be delivered to the right place. So these identifiers, these URLs, allowed computers connected in a network to exchange messages and to know which computer they were talking to and where to send the message. And being quote-unquote universal, it was a comprehensive and standardized system that became the foundation for what Berners-Lee called the World Wide Web. The second component of his system was called Hypertext Transfer Protocol, HTTP, which we often see in our in addresses that we use when we're navigating the internet. And this is a protocol that allows computers to connect in order to read otherwise disparate internet files. Not much more to be said about that without getting into the technicalities of how the system works in binary, actually, which is, of course, suitable for a course in computer science, not necessarily history. And the third component of Berners-Lee's system was called Hypertext Markup Language, HTML, which you may be familiar with as well. And this was a relatively simple computer language that someone creating an internet message to insert so-called hotspots or links that, if clicked, would instantly switch the on-screen image to something else. So, for example, a research article could include visible indicators, usually the underlining of a term. We're so used to seeing that with our email links, for example, that when clicked on with a mouse, would cause the browser to move to another article on the subject, to a linked article, a linked site on the internet. Now, the history of the term hypertext is actually interesting in and of itself. It was devised by technologist Ted Nelson in his actually 1962 book called Literary Machines, as a system that would allow people to interrupt themselves while reading through material in the traditional linear way from beginning to end, and transport themselves non-linearly to related material. If you've ever tried to read a text that has a significant number of footnotes included on the page, where in order to actually to understand the text, you have to look at the definition of a certain term that is footnoted down at the bottom of the page. This is the idea of hypertext, where you interrupt your reading in order to go to a link, which is in this case the footnote at the bottom of the page, that defines the term or gives a little bit of background on the emergence of the term before you return to the more consecutive or a linear text. And sometimes you sort of have to reset your switches and remind yourself what it was you were reading. And a quarter century later, after Ted Nelson in his 62 book Literary Machines invented the term, Berners-Lee devised the HTML coding that made non-sequential reading on the internet possible. And the importance of Berners-Lee's innovations in terms of scientists, for example, finding sites all around the internet was a landmark. But for the rest of us, the content was pretty bland. It was still just this black and white text that, as I said before, really only a researcher could love. But it was in 1993, shortly after Berners-Lee introduced these three elements of his system, that the internet as we know it began to come to life. At the University of Illinois, grad student Marc Andreessen, who was actually mentioned in our last lecture from the Bolter and Gruson reading on page 304, he developed the software program Mosaic that improved the interconnections that permitted scientists to browse each other's research. Enthusiasm for the potential of this browser, as it was called, that's right, the origin of the term browser is associated with Marc Andreessen's Mosaic, quickly swelled. And by tweaking Mosaic, Andreessen and a few colleagues at the University of Illinois created a new browser called Netscape. And this would connect any of the three disparate computer operating systems that were becoming commonplace. And those three were Microsoft Windows, Apple's Macintosh OS, and at the time, Unix. So Netscape was a point-and-click system through which anyone with a computer could unlock more content than had ever been conceivable in human history. And competing browsers certainly followed and eventually eclipsed Netscape in their ability to provide browser services to an increasing consumer base than Netscape was able to do. And it was with Netscape really that we see the beginnings of the commercialization of the internet, which is closest to the internet that we experience in our use of it today. This would be gradual, really the commercialization of the internet. I mean, it had already started, but it was very gradual. It was very clunky with these largely text-based available web pages. And it really switched into high gear with the introduction of Netscape and then the introduction of more sophisticated web browsers that followed it. And a few retailers displayed their wares, and they took orders online and then shipped their products to customers. And so at that point, the old point-of-purchase concepts in which consumers are attracted at a store with displays and posters, it took on a whole new meaning. In the new cyber world, the point of purchase was not the merchant's shop, but the consumer's computer screen. And sites for pitching products and services, some of them complete catalogs, they sprouted by the thousands. But beyond the commercialization, in terms of the history of the technological development of what we understand as the World Wide Web, it's really hard to overrate Berners-Lee's accomplishment. The internet is the information infrastructure that has eclipsed many other media and will likely entirely eclipse and maybe even erase other forms of analog media given time. And some theorists have even likened Berners-Lee to our old friend Johannes Gutenberg, who 400 years earlier had launched the age of mass communication, as it's called, with the movable type and his Gutenberg printing press that made a mass production of the written word possible that we have looked at extensively in the earlier lectures of this course. And just as Johannes Gutenberg brought mass production to books, the other primary print media, magazines and newspapers, followed with the increasingly technological sophistication of different types of printing presses. And people never had a problem recognizing the difference among books and magazines and newspapers. But when sound recording and movies came along, they too were quite distinctive, as were radio and television. All of these analog media were really, really easy to distinguish one from the other. Today, however, the traditional primary media are in various stages of transition to digital form, and all distinctions are blurry. The distinction between a newspaper and what you get on your iPhone in terms of print journalism is blurring these analog distinctions. The iPhone tends to be the source for all of our media sources, or the computer or the internet in general. And in a world in which works, text, music, video, and all of these traditionally analog forms of media are stored and transferred digitally, and consequently can be copied and distributed globally in an instant and for almost no cost, traditional conceptions of copyright and intellectual property became increasingly problematic, especially for centuries-old industries like the newspaper and other offspring of the printing press. In terms of how to maintain advertising profits. These industries grew up around more traditional copyright landscape, treating content as a form of private property. Somebody owns a movie, somebody owns a song. But once a song, for example, is digitized and it's downloaded to somebody's computer, before we had new gatekeepers online, it was really easy to share that. So effectively, a person could buy a song professionally produced by a rock band or a pop performer and then give it to all of their friends through the internet effectively for free. And we saw the emergence of companies like LimeWire and BearShare that were designed actually for inter-office sharing of programs amongst people working within a corporate setting, but they actually became publicly used to share things like videos and movies and songs. And so in the first decade of the 21st century, there were a number of legal cases that effectively shut these companies down. LimeWire and BearShare are now considered illegal file-sharing platforms, and so the companies discontinued. And it's true, large corporations responded to this new media where everything was digital and easily shareable at the point of reception as well as the point of production by shoring up their legal copyright borders. And this actually resulted in significant convergence not only of the technology into the iPhone, but actually convergence of corporations, with a few major companies coming to dominate the internet and working against the utopian illusion of democratization that others see as the fulfillment of the internet's technological promise for a more democratic and participatory future. And on that somewhat dystopian note, unfortunately, I'll bring Lecture 11 to a close and just conclude with the positive reminder that we have only one lecture left in next week's material on globalization, followed by our online quiz, which will be conducted the same way it would have been in class, only it'll be in a private setting now with whatever device you have available. Time limitations will be in place. But this is our point to reflect on the internet, which is a really pervasive media form that we all live with and live in many ways, in terms of virtual landscapes and mediascapes. And isn't it interesting to understand now some of the history that underpins this social form that we are so used to, we just take for granted, and yet it's really less than a 30-year history underpinning the widespread use of the internet and what Berners-Lee called the World Wide Web. So have a good think about the material. Once again, review the PowerPoint slides that go along with this video lecture. And I'll thank you for your time and attention, and encourage you to watch, if possible, back-to-back the next video lecture and our last in the course on globalization. And until then, have a great week.